Hello and welcome. So in this video, we're going to cover packet tracer and packet capture from the perspective of the ASA and get into some examples of how to use that for troubleshooting and kind of figuring what's going on by looking at a particular interface and kind of understanding what should be happening for kind of end-to-end connection, and try to figure out what's going on and use these tools for troubleshooting. So we're going to get a packet capture running. So capture, the name of it is C. Going to focus in on the inside interface of the ASA, and then want to match on the IP of the Ubuntu 10.50.3.5 and the IP of its DNS server 192.168.3.254, which is reached through the external connector for the physical network that this lab is connected to. And the Ubuntu is getting its network info via DHCP. And so we can see here that indeed the configured DNS server is the same as what we set up in the packet capture. And so I'll go ahead and generate some traffic. So we'll do nslookup, cisco.com. And so there is an issue here, and this doesn't come back with any info, and so this is going to time out. And let's look at the packet capture. So I just do show cap C, C being the name of the capture, and so we got tons of packets here, 132. But it's kind of all the same story here, which is the Ubuntu is definitely sending traffic that's hitting the inside interface of the ASA, and destined for the IP that we're for its DNS server. But nothing is coming back, and we can see a bunch of TCP sends are happening. But since nothing is coming back from the DNS server, we're never going to have the TCP handshake. And normally I would expect some UDP traffic, but for whatever reason, it's not trying UDP right now. And so yeah, it just timed out. So, what is going on here? So the next thing we can do is like, well, let's use packet tracer to see if this is actually allowed or not. And so I got packet dash tracer input inside interface. We're going to look at it, since we're doing DNS, and we're going to do Icmp, and same source IP, and then these are the Icmp codes for domain name. So I think this is correct usage here. Since we're doing DNS, we want to do in packet tracer, we want to reference Icmp, source and destination IP addresses, but you have to put in the codes. And then these codes seem to be correct for the domain name request and reply. So I think that's correct. But so there currently is nothing blocking this. There's no access list, or there's nothing that would be blocking this traffic right now. And then but I just want to see that from a packet tracer perspective. And as we go through the different phases, everything is allowed. So route lookup sees the next hop, which is really going to be the inside of this, the iOS router here, which is kind of, if going back to the previous videos, this is kind of representing the ISP in a simulated internet kind of a situation. And then just go through these. Phase 6, we know Icmp is being allowed in the policy map here, and just keep going through, and everything's allowed. So we know that traffic is getting to the inside interface of the ASA. we know nothing's blocking it. It's looking to forward it. It's got the next hop. So what is actually going on? And what's going on is there's a missing piece of routing. So there's OSPF is happening between the ASA and these two routers, and but the network for the inside interface of this ASA is not being advertised on um, O- OSPF, sorry. And because of that, when the traffic is hitting the DNS server and being sent back, um, there's no routing to this particular network, and so that's why it never gets back to the ASA, because there's no routing. So this iOS router does not know how to get to this 10.50.3.0/29, and because it doesn't know how to get there, then of course traffic doesn't show up on the ASA, and then ultimately no response, connection timed out on the Ubuntu. So basically, this is this problem that I've set up is a routing, but the idea here is that we saw the traffic show up on the ASA, so we know there's no problems with it getting from the Ubuntu to the ASA. And then we also know that there's no forwarding issues, because what we saw from Packet Tracer, it's looking for the next hop, everything is allowed. And then in reality, what was happening is what it was getting into the DNS server, it was getting a response, but it's pretty much being dropped at this iOS router, because there's no routing for it to get back to the original source. We'll fix that. So we'll advertise this interface on the ASA. And that should fix our routing problem. So now we have that showing up in OSPF. So what we'll do here is we'll do clear cap C. I'm going to be clearing stuff a lot, because that way keep the output really clean, and try to control this as much as possible. So there's good examples on the video here. So let's try it again. And sure enough, we do get a response. We do get good DNS resolution, and we'll do show cap C. And then right off the bat, where it's majorly different, where we do have do get the TCP. Well, actually, sorry, this isn't going to be a handshake, but we do see back and forth traffic between the Ubuntu and the DNS server, and obviously we knew it worked here. And then you can see the packet capture is quite different and looks a lot better. There's bidirectional traffic here, so that all makes sense, and that's cool. So that was the first example, and then I'm going to take the routing off. We'll go ahead and remove that routing, because the rest of this is going to be over the site-to-site tunnel. And just for integrity of this lab environment, there should be no routing for the networks, inside network of the ASA and inside network of the CSR. We don't want that routing on OSPF, because that wouldn't be a good simulation of actual site-to-site tunnel over internet. And so the way that routing is going to be happening between these two networks, that is the encapsulation of the IPsec between the two peers, which obviously there is routing between these two peers, the ASA and the CSR, and that's done through OSPF. but we don't want these local networks to be routed because that wouldn't make sense for a VPN tunnel lab. Oops, I want to do no to that one. Okay. So then if I go back to this iOS, that should be gone. And you can see this iOS has nothing showing up on OSPF because the three things that are connected to are all local routes, connected routes. So we'll go to the next example where we'll do clear cap C. So this was same concept of the port 80 test we do in the previous video, where we're going from the local Ubuntu to the remote Ubuntu, and we want to send a port 80 test. And that's allowed by the VPN filter that was part of this. So we'll set up a packet capture. So this time, same concept, capture, we'll call it C. We care about the inside interface. We're going to match on IP this time. Source IP, destination IP, and yeah. So we got that capture running. And then we'll run this curl command, which gives us, all the HTML stuff for the default page for Apache, so Apache 2. And I think on the previous video, I was like grepping on like default or something. So yeah, same thing. So we can definitely do a port 80 test from the local Ubuntu to the remote Ubuntu, port 80 for its Apache server. And let's see what that looks like on the packet capture. So show cap C, and then back and forth. So we can see TCP handshake happens, and then a bunch of port 80 traffic comes back over to the requesting Ubuntu. So that's all normal, looks correct, a bunch of back and forth traffic that we saw work, and so it makes sense that it looks like that in the packet capture. And then the point is, let's see what that looks like in packet tracer of something that's just allowed and shouldn't have any issues. And what I put in my notes here is on one of these phases, shows the filter. There's because we have so if with the previous video with the VPN filter, not all traffic is allowed over the tunnel, and only certain traffic is allowed through this VPN filter. And then see this here, and in this case, when it runs on phase 10, where it says filter -AAA, that's I believe the VPN filter that we have set up for this tunnel, which was covered in the previous video. So that's just an example of where everything works. You can see it in the packet capture, we can see it in packet tracer, then obviously just, running it from the Ubuntu. But then let's do something that doesn't or shouldn't work and is not allowed. So I'm going to clear the packet capture again. And now this time it's going to be the same capture, same source and destination IPs. But this time we're going to be doing port 443, which would not be allowed by the VPN filter. So I'm going to go ahead and run this curl. So in this case, curl minus k, and we're doing HTTPS this time, which will be port 443, and then we get a connection refused right off the bat. And so let's look at the packet capture. So we know that traffic is definitely showing up, right? So we sent that port 443 traffic from the Ubuntu, definitely showed up on the inside interface of the ASA. You can see the source IP, destination IP, and then destination port 443. And then there's a reset. And you can speculate as to, could be the ASA, it could be the Ubuntu, or anything, could be anything in the end-to-end between the ASA itself and either of these two routers, or even the Ubuntu on the far right, the destination. You wouldn't really know for sure. But we'll run packet tracer, and we'll see that this is actually blocked by the VPN filter. So same packet tracer, and then the only difference is now we're specifying a destination port of 443, which matches the exact curl command that we ran on the Ubuntu. And as we go through, this is drop. So phase 10 drop, filter AAA. So the point here is we know that the port 80 to this specific 172.16.20.2, that's allowed over the site-to-site VPN based on that VPN filter from the previous video. And then, that all works, looks good in packet tracer, looks good on the packet capture. And but when we do that same exact concept, except for changing it to port 443, which is not allowed on the VPN filter, then we saw that it didn't work. And we saw that the traffic definitely showed up on the ASA like you would expect, but there was a TCP reset. Well, where did the reset come from? Well, it's safe to say that it came from the ASA, because on phase 10, that hit the VPN filter access list. It was dropped, not allowed. So that's a pretty straightforward and pretty good example there. So we'll do clear cap C. And then let's see, what's the next example? Let's get the same packet capture running between the two IPs as we've been doing. And so another thing that is allowed over the tunnel, due to that VPN filter that's in place, is Icmp. So I can ping 172.16.20.2, and let's look at that in the packet capture. So it didn't totally clear before, so we're just going to focus in on these. There's DNS traffic happening that in the midst here. So because I did clear that capture, so that's fine. And we could specify it further down, but there's no point. So you can definitely see in the packet capture, there's echo requests, echo reply. So that all looks correct. But let's do something to break that and see what it looks like. So we'll make a access list on the inside interface of the ASA that's going to say deny any traffic from the Ubuntu at 10.50.3.5 to any destination inside interface in the direction of in. So, from the Ubuntu to the ASA inbound on the inside interface. So I'll copy these. And then, so the second line here, so we're dropping anything for the Ubuntu host, and then we're permitting anything after that. And then this access list is getting assigned to the inside interface, as I mentioned, and kind of like the input direction. Okay. So pretty much what that means is this Ubuntu is just not able, won't be able to communicate. No traffic from it is going to be allowed across the inside interface. So run the capture again, and send that ping traffic. And of course, now there's no response because we're blocking it on this inside interface via that access list. So if we do show cap C, we see that it does show up in the packet capture. So it's definitely getting into the inside interface of the ASA, but it is not being forwarded. So let's see what that looks like in Packet Tracer. So we got Packet Tracer input inside. Now we're going back to Icmp, source IP from the Ubuntu, and then again you have to put in Icmp codes. And there's like a code and a what is it? There's a oh yeah, there's an Icmp type and then a code. So what I have is type 8 with code 0, which is so type 8 is the Icmp echo, and then there's like there's no code for this one, so you use 0, and then that'll show if that should be a good representation of Icmp from the Ubuntu destined to something on an outside network. That's obviously got to go across the inside interface. And what do we have here? So we get to phase 4, and it's dropped on an access list, and then it shows specifically the access list that we made. So that all makes sense. But so the idea here is like you can see that we sent ping traffic, we got no response, had the packet capture running, and we know for sure that it showed up on the ASA, which is helpful to know. And then, so what's going on here. And then, so we use packet tracer, and sure enough, there's an access list that is denying this. So we know exactly why the ping is not working in this case. All right, so I'm gonna go ahead and end the video on that last example. I do have another one that I wanted to do, but I'm having some issues. So I'll get that sorted out and probably put it into another video. So thanks for watching. Hopefully that was helpful. Very kind of initial kind of first pass look at packet tracer, packet capture. Even some of the most simple uses of that can be very quickly show you what's going on to help troubleshoot and isolate down. So thanks a lot. Have a good day, and we'll talk to you next time.